All right, so consumers' behavior starts with choice and utility theory. Let me write down 2.1, choice and utility theory. Choice and utility. So consumer, when consuming something, consumer has some choice, whether consumer are going to consume goods or not. It is his or her choice, and it is depending on the behavior of choice is called preference, consumer's preference. Preference. And what is utility? Utility is something called satisfaction. The meaning of utility is called satisfaction. So when a consumer consumes something, he or she gets satisfaction from this utility, and this satisfaction has some criteria that gives some utility. Okay, so utility can be, in the beginning of the theory, utility, the economists say that utility can be measured. Okay, so utility can be measured by units. Or it can't be measured by unit. Measured by unit. We'll understand after the class, we'll understand whether this one is true or that one is true. When utility can be measured by unit, it is called cardinal utility. Cardinal utility. When we say that it cannot be measured by unit, it is called ordinal utility. Okay, ordinal utility. That means utility cannot be measured. We'll see in the next section. We'll see why utility cannot be measured, why utility can be measured. Okay, so in this, let me give you some example. Suppose we have apple. Okay, so number of apple in column number 1, number of apple. Maybe 1, 2, 3, 4. 4 units of apple. And if you consume apple, you are getting satisfaction. That is called utility from apple. Utility from apple. Okay, and utility from apple, those who believe that utility can be measured, suppose they said that their unit of measurement is utils. So from this unit of measurement is called utils. Okay, utils. So suppose utils can be said that we are getting from 1 apple, we are getting total utility, TU. Total utility means, this means T, total utility, TU. Let's suppose from apple, first apple, we are getting total utility 10 utils. 10 utils. So in utils. let's think about util as hypothetical unit, like some other units called age, weight, or height, etc. So utils is the utility units of utility. So suppose the first apple, we get 10 utils. What do you think? What should be the utils for this second apple or 2 apples? Any idea what utility you are getting from 2 apples? 1 apple, 10 units, 2 apple?
20.
20. And if you add 1 more, then what happens?
30.
30. And if you add 1 more,
40.
then what happens? 40. Now, do you believe that you are getting exactly the 10 units when you were eating second apple?
Yes, sir.
Yes or no?
Yes.
How? When you ate first apple, you get 10 unit of satisfaction. But do
The
you think
difference
that?
is constant, sir.
But is it a rational behavior to get constant utils? Suppose you were drinking a glass of first glass of water when you were thirsty. Okay. Then you are supposed to drink second glass of water. Do you get the same level of satisfaction? Yes or no?
Sorry, sir, I don't understand.
Suppose you are very thirsty. So I give you a glass of water, and you said that I need more glass because I'm very thirsty. So do you think that the utility from the first glass and the utility from the second glass are equal?
No, sir. I don't
No,
think so.
sir.
No, sir.
Why not? Why not?
It is helping me.
Because from the first glass, you have already, I mean, nourished yourself, and thirsty is less now. The second glass, you said that I'm already have first glass, so second glass will give you less utility. Third glass, you will say that no, I'm not thirsty now, enough is enough, I'm not going to drink more glass of water. And the fourth glass, you will say that no, it is not possible for me to drink. So utility is not constant for subsequent consumption. So maybe for the second glass, second apple, it is not 20, maybe it is 19. I mean, 2 apple, 19. 3 apple, it is not 30, maybe 27. 27 unit of satisfaction you are getting. Maybe 4, you are not getting utility for 40, you are just getting 40, suppose 34. Okay. So you see there is a change in apple, change in, suppose a number of apple is Q number of apple. So change in Q and change in total utility. Total utility. You see, there is a change in, I mean, there is 1 unit change in Q, all right? And the unit of change in Q is first, for first unit, you are getting maybe from 0 to 1, it is 10, right? From 0 to 1, it is 10. So when you have consumed 0 apple, then it is, I mean, 0. then you consumed first apple, then the change in from 0 to 1, 0 to 10. So change is 10. You see, when you move forward, then from 1 apple to 2 apple, you are getting, there is a change in utility is 9, right? So change in Q is 1, change in TU is 9. When you again move forward, you see that it is 8, right? 19 plus 8 equals 27, so 8. When you again move forward, you apple the fourth apple, you eat fourth apple, then it is not 8, it is 7. So you see that your total utility is not at constant rate. Rate is not constant. Why? Because it is our human behavior. Rate is not constant. Our satisfaction level is not with the same rate. Okay. So first apple, we are getting 10 utils. 2 apples, not 20 utils, we are getting 19 utils, suppose. 3 apples, again, there is a less number of utils you are getting, 27, not 30. Okay. And 4 apple, it is not 40, it is 34. So you see that there is a rate is not constant, it is diminishing. Rate is diminishing. Okay. So this is the diminishing, this is called marginal utility. Marginal utility. That means marginal utility is diminishing. Diminishing marginal utility. Diminishing marginal utility. Okay, diminishing marginal utility. Marginal utility means mu. Now, can you define mu? What is mu? Can you define mu? Let me help you. For additional mu definition, for additional unit of consumption of a certain good, there is a change in utility. There is a change in utility. Okay, and this change is called marginal utility. That means, let me add a page. That means marginal utility is for 1 unit change in consumption, what is the change in total utility is called marginal utility. Okay, it's called marginal utility. That means marginal utility is, you can write down the equation as marginal utility is d total utility divided by dq. Okay. Now let us make this idea in mathematical. Okay, so utility is a function of goods x1, x2, up to xn. So we are getting utility from various goods and services we have in the economy. So because we are two-dimensional, so we can call it as utility is a function of x1 ceteris paribus. That means all other things, all other goods and services are constant. So when utility is a function of x, or you can make it simplify, utility is a function of x. X is a good. All right. Now, what is the marginal utility? Marginal utility is du dx, or maybe you can call it as q1, q2, qn, or du dx is your marginal utility. Okay. All right. This is mathematical illustration of marginal, utility. Okay. Now, can you make graphs of this? If I say that this axis is for total utility and this axis is for x or q, consumption of good x, or maybe q or x, whatever maybe you like. So our total utility function look like this. This is our total utility function. Okay, you see that the behavior of the curve is increasing at decreasing rate. So when your curve is concave, then it is increasing at decreasing rate. That is what we have seen in the first page. You see, increasing at decreasing rate. So rate is decreasing, but the total utility is increasing, right? So total utility is 10, 19, 27, 34, but at the rate of decreasing. You see? Have you seen this? When
Yes, sir.
it is increasing at increasing rate, the curve could look like this. Curve could look like this. Increasing at increasing rate, like this. So it is increasing. Total utility is increasing at increasing rate. Increasing at increasing rate. But above graph, increasing at decreasing rate. Can you tell me if it is increasing at constant rate, what could be the curve look like?
Straight line.
Straight line.
Straight line. It will be straight line. So we are not, going for the rational behavior is not increasing at increasing rate or straight line. It is increasing at increasing rate. Why? Because we have seen in the previous that it is marginal utility is decreasing. So rate is decreasing, but total utility is increasing. So increasing at decreasing rate. And this obeys the law, and it is called law of diminishing marginal utility. Okay. This
Sir, will you
obeys
repeat it
the
again? The
law of diminishing marginal utility, because marginal utility is decreasing, total utility is increasing. So it is called law of, write down the law of diminishing marginal utility. Law of diminishing marginal. It's a law. law of diminishing marginality. Okay.
And can you please repeat the statement? I mean, what it says.
No, this is going to be recorded, so I'm not going to repeat it. Okay, because repeating is wasting of time. All right. Okay, let me erase this law of as we know that law of diminishing marginal utility, that means total utility is increasing at decreasing rate. The rate is called marginal utility, increasing at decreasing rate. All right. So we are going to see the behavior of this as total utility is with this shape, and this shape is called concave shape. All right. Total utility is increasing at decreasing rate. That's why it is this shape. If it is increasing at increasing rate, it was convex shape. And if it is increasing at constant rate, it was straight line. But normally, our total utility curve look like this. Okay. So remember this law of diminishing marginality. Can you define why this? Can you explain why this law of diminishing marginality is there? Why this law is this is a law? This is because our marginal utility is declining. In our previous board, we see that our marginal utility is declining 10, 9, 8, 7. But total utility is increasing. Marginal utility is the rate of total utility, rate of increment of total utility. You see, 1 unit change in Q. What is the change in total utility? Is called marginal utility. Okay, so marginal utility is diminishing. If marginal utility is 10, 10, 10, 10, it would be the utility curve is a straight line. If marginal utility is 10, 12, 15, 17 or something like that, it is called increasing at increasing rate, the convex curve. But because marginal utility is decreasing, it is called law of diminishing marginal utility. Marginal utility diminishes when you consume more and more goods. When you consume more and more goods, your marginal utility is decreasing. Okay. All right. Now, there is a concept called utility maximization. Utility maximization. Why utility maximization is there? Because consumer satisfaction has reaches at maximum and then it fall down. You see the behavior. So consumer move like this, increasing at decreasing rate, and then reaches its maximum. Okay, at this point. So this is called maximization of utility. And then after the maximum, the utility fall down. This part is declining. You see, this part is declining. Now, can you tell me how the marginal utility curve looks like? You see that marginal utility curve is following the diminishing law of diminishing marginal utility. So what is the curve looks? What is the curve marginal utility curve look like? If I draw a curve below for marginal utility like this, so what could be the marginal utility curve? Suppose it is X consumption of X good and it is marginal utility. How do you draw this curve? Is it upward sloping, downward sloping, or what? Any idea? Is it upward sloping? Marginal utility is upward sloping or downward sloping?
Downward sloping.
Why downward sloping? Because in the data set, we have seen that marginal utility is 10, 9, 8, 7. So it is downward sloping. Why downward sloping? What is the law?
Law of diminishing marginal utility.
Marginal utility. That's why it is downward sloping. Okay. Now, how can we draw this graph? I cannot draw like downward sloping like this, or like that, or like this. How can we draw? It is following a rule. You see that. Have you done your, in calculus or in optimization? Do you see? Do you know what is the rule for optimization or utility maximization? What is the rule for any function? What is the rule for utility maximization?
Sir, derivative is positive.
First derivative.
First.
First derivative 0 and second derivative is negative.
Yes.
Okay, so first derivative is 0. So any optimization dy dx is 0, right? And for max d2y dx2 is for max negative. All right, for min positive. Okay, so this is the rule for optimization. Now tell me, if this is the maximum point, what could be the in this point, what is the mu? This point is maximum
0.
0. So here, if we draw a corresponding line, this point should be 0 mu. Why? Because here at this point, dtu, dq or dx, suppose q means quantity of good x, dq is equal to 0. And do you know that this tu dq is marginal utility? This is actually what? Marginal utility. So at this point is marginal utility is 0. Mu is equal to 0. You see this? Now it is very easy to draw a marginal utility curve. How? Because we know that it is downward sloping, then we can draw marginal utility curve like this. Simply we draw without going for any detail, we can draw marginal utility here. You see that after mu equals 0, then what happens to tu? Tu is declining. So when tu is declining, then mu is what? Mu is negative. At this point, mu is negative. So you see that mu is negative here. So this is mu. After this point, mu is negative. Okay. So now we see that we have seen the mathematical function of total utility. This is not marginal utility. This is actually total utility. Marginal utility is this. Marginal utility is du dq, and this is total utility. This function is tu function. So this is mathematical, and previously we have seen graphical. You see that this is graphical representation of utility. So number of apple, q 1 2 3 4, total utility 10 19 27 34, and marginal utility 10987. These are the graphical representation, I mean, the data set of utility. Okay, and this is equation function, I mean mathematical, and this is graphical. So here math for utility, here graph for utility, and there previously we see the data set of utility. Okay, data set. Okay, now if I ask you a question, let us go for the fresh page. If I ask you a question that graphically show the relationship between TU and MU, our answer is this one, right? Got it? But how do you explain? What is the explanation? Explanation is you can make it point by point. You can say that point number 1, total utility is increasing at decreasing rate as I mean following the law of what? Following the law of
Diminishing marginal utility.
Thank you. Following the law of diminishing marginal utility. So this is point number 1. Point number 1, point number 2. TU reaches at its maximum and then fall down or decline, fall down. Okay. Number 4. When TU is increasing at decreasing rate, MU decrease. Okay. When TU is at max, MU equal to 0. When TU declines, MU is negative. All right. So this is the explanation of graphical representation of the relationship between TU and MU. Okay. All right. Now, so far we have discussed about the cardinal utility. That means when utility is quantifiable. Cardinal utility. That means utility is quantifiable by a unit called utils. Now, this is the idea of marginal economists, but later the scholars say that no, utility cannot be measured. Utility can't be quantifiable. My question is why? Why it can't be quantifiable? The answer is it is not quantifiable because it is a vague term. The util is not, compact unit. Why? Because the problem is called interpersonal problem. Let us go for the next page. Problem of quantification. Quantification in utils. What is the problem? Problem is called interpersonal comparison. Interpersonal comparison. What is the interpersonal comparison? Interpersonal comparison is something like, suppose in the previous pages we have seen that we see that for 1 unit of apple we assign 10 utils, second 19, third apple 27, fourth apple 34. But maybe some other person say that for the first apple I am not going to give 10 utils, I'm going to give 15 utils or 20 units, whatever may be. Interpersonal comparison is there. You see, interpersonal comparison. Someone says that 1 apple is 10 utils. Other will say that 1 apple means 12 utils. I'm going to say that no, I love apple, so my util is 20. Another person say that I don't like apple, so my utility is only 5. So this is called interpersonal comparison, problem of interpersonal comparison. That's why some scholars say that utility cannot be quantified, it should be ranked, not quantifiable, ranked. So we can rank the utility between the maybe two goods. Okay, so suppose we have utility. Suppose we are going to say that our utility is a function of only 2 goods, x1 and x2. Okay, so when 2 goods are there, we can make cardinal utility. In order to make cardinal utility, we are going to say that utility is a function of only x1, and we are making x2 as constant. Then we are going to see utility curve like this. Okay, total utility. So this one is increasing 1, 2, 3, 4, and utility is going down like 10, 19, what is then 27, then 34. So in this way, all right? But scholars say that no, we are not going to quantify them in this way. We are just make the rank. That means combination of good x1 and x2 for ordinal utility. We are going to say that for ordinal utility, we are not going to make this constant. We are going to say that utility should be constant, and because we have two-dimensional space, then our function both x1 and x2 could be variable, and u is constant. All right, so we can say that we can make some combination of x1 and x2, make some combination of x1 and x2 so that we are getting the same level of satisfaction. That means our utility is the same for combination. All right, suppose we have four combination A, B, C, and D. This combination gives, we are taking one unit. Suppose our x1 is apple and x2 is banana. Okay, so we are going to consume two goods. So either we can eat one apple and suppose a 10 piece of banana. Let's suppose, it is not possible, but let's suppose. Then this will give you, suppose u1, no, u0, or u constant u. It is not one or two. It is just same utility or same level of satisfaction. Now suppose you are increasing the number of apple consumption. That means if you consume 2 apple, in order to keep the utility constant, you need to sacrifice x2. That means suppose we need to sacrifice by 5 unit. So this is a combination, 2 apple and 5 banana gives you the same level of satisfaction, u bar. Okay. Now suppose you increase another apple. So suppose it is 3. Okay, 3 apple. Then you need to sacrifice again banana consumption. Suppose it is 3. So 3 banana and 3 apple is giving you the same level of satisfaction. So we are now not going to quantify utility. We just rank. That means level is the same. Okay. Suppose we add another 4 apple. We need to go for maybe 2. Okay. Now suppose we are going for, suppose another point, maybe 5, then 1. So these are the combination that gives you the same level of satisfaction. Our utility remains the same, but combination maybe 1, 2, 3, 4, 5, and 10, 5, 3, 2, 1, or 5. Okay. All right. So this is the combination, and we are not quantifying our utility. We are just making the combination of goods X1 and X2 so that we can get the same level of satisfaction. Okay. All right. So you see that the utility remains the same, but combination of goods varies. Okay. That means when we see that our unit of change is X1 is 1, 2, 3, 4, 5, 1 unit change. For 1 unit change, our sacrifice is diminishing. You see, our sacrifice is diminishing. So this is called MRS. MRS X1 and X2. The elaboration of MRS is called marginal rate of substitution. Marginal rate of substitution. So you are substituting, I mean, when you are increasing the number of X1, you are substituting X2. That's why it is called marginal rate of substitution. Let me make this corrected. Marginal rate of substitution. Okay, marginal rate of substitution. Now, this marginal rate of substitution is increasing or decreasing? Is it increasing? The rate is increasing, decreasing, or constant? Which one is correct?
It's decreasing, sir.
Increasing or decreasing?
Decreasing.
Decreasing. Why? Because you see that if you see, this is actually nothing but dx2 dx1. Okay, dx2 dx1. You see that if we say that dx2 dx1, so it will be 5, then 2, then 1, then 1. Okay, so it is decreasing. All right. So this is called decreasing or diminishing marginal rate of substitution. Diminishing marginal rate of substitution. Diminishing marginal rate of substitution. Okay, diminishing marginal rate of substitution. Now, when it is diminishing marginal rate of substitution, if we try to make the graph for that, so what will be the graph look like? If I say that it is X2 and here X1, what could be the shape of the curve? Remember, in the first class, we have talked about PPF. And PPF, the rate was increasing, not diminishing. So when increasing, the curve was look like this. Okay. So suppose you are increasing 1 by 1 unit, then you see that your sacrifice is increasing, the gap is increasing. Okay, when it is decreasing or diminishing, when the rate is diminishing, then your curve should be look like this. For increasing, it is concave, and for decreasing, it is convex to the origin. Convex to the origin. Okay, convex to the origin. All right. If it is convex to the origin, then it looks like this. So what is that? This is because, so if we draw the graph, suppose we are in previous page, if we draw this graph, you can draw this graph here by using the graph, I mean data set. You can draw the graph. Suppose our graph look like this. We are trying to make graph of that. So x1 is increasing by 1 unit, 1, 2, 3, 4, 5, and x2 is increasing. Suppose it is for 1 x, suppose it is 10. So here 10. In the middle it is 5, maybe 5 here. 4 maybe here, 3 maybe there. Okay, so for 1 it is 10 here, for 2 it is 5 there, for 3 it is 3, maybe this, for 2 it is 2, maybe this is 2, for 5 it is 1, maybe this one. You see that the curve, if you connect this dot, then you can get a curve which is convex to the origin, right? And why it is convex to the origin? Because MRS is diminishing. Now tell me, when MRS is increasing, then what could be the shape of the curve? It is
Concave.
concave. And when MRS is constant, suppose
Straight
10,
line.
10, 10, 10, 10, it is straight line. Okay, so I suppose that you understood very clearly. So this graph looks like this, and the name of this graph is called indifference curve. IC, I mean indifference curve. Why it is called indifference curve? Because consumer is indifferent along the line. Can you tell me why consumer is indifferent along the line? Can anybody tell me why consumer is indifferent being on this? Let me go to the previous phase. Being suppose it is point A, it is point B, it is point C, it is point D, it is point E. So A, if we move from A to B, B to C, C to D, D to E, consumer is indifferent. Why? Why consumer is indifferent being at this point or this point or this point or this point or this point? Why consumer is indifferent? Indifferent means doesn't matter where consumer is. Can anybody guess why consumer is indifferent on any points on the line? There are infinite number of points on IC curve, right?
Yes, sir.
So why consumer is indifferent being at point A or B or C, whatever may be, consumer is indifferent. Why?
Maybe because in ordinal utility, you always have to maintain the utility constant. So that's why the
Thank
consumer
you,
is
thank you, thank you, thank you, thank you. It is this is the main reason. Main reason is we see that in our case, in ordinal utility, as a function, we are keeping utility constant. So whatever may be the point, whatever may be the case, here any point gives the IC on any point at any point on IC, consumer gets the same utility or same level of satisfaction, same utility or same level of satisfaction. Okay, consumer is getting the same level of satisfaction. Okay, so now, so we have got indifference curve. Now we need to make some characteristic of, I mean, properties of IC.
Sir, can we keep the class up to this, please, sir?
Yeah, just I'm writing the properties and our class is finished. Okay.
Okay, sir.
I'm writing the properties and we'll discuss in the next class after the properties. Okay. So just know the properties of the indifference curve and then we finish our class for today. All right. So properties of IC. Properties of IC number one. Property number one. What is the property number one? Property number one is IC is downward sloping. Property number two is IC is convex to the origin. Number three is higher IC gives higher level of satisfaction.
So I have a question.
I'm writing and then I will take your question. Okay.
Yeah. Okay.
Satisfaction. You see that higher IC means suppose our income increase. So we can, I mean, there is a series of IC. That means here there is another IC. There is another IC can be there. Another IC can be there. This when we write down many IC, then it is called indifference map or indifference map. Indifference map. That means if we move from one IC to another IC to another IC, so the more, I mean, the higher you are reaching the IC, you are getting higher level of satisfaction. On the same IC, you are getting the same level of satisfaction, but if you move forward, then you are getting higher level of satisfaction. Suppose it is 100. This here utility is 100, then maybe it is 200, then it is 300, then it is 400. Maybe we don't know, but we can say that satisfaction level is higher. Okay. Fifth properties is, a fourth property is no two ICs intersect. In the next class, we'll prove this, why no two ICs intersect. That means IC curve cannot be like this. If I draw IC map, we cannot draw in this way. I mean, no interaction. They are parallel. So the IC map are parallel. Okay, parallel to each other. ICs are parallel. That means this indicates that ICs are parallel to each other. Okay, so we have four properties. All right, this is obvious, downward sloping, because why downward sloping? Because if you want to increase the number of x1, you have to decrease the number of x2. That's why it is downward sloping. It is obvious. Convex to the origin, why? Because the rate is diminishing. That's why it is convex to the origin. It is also obvious. Our rate, the rate, this is because of diminishing MRS. All right, diminishing MRS. This is because of consumer is rational consumer, because the more consumption, the more satisfaction, rational behavior, rationality. In the next class, we are going to prove this, why no two ICs are intersecting. We are going to prove this in the next class. All right, so someone has question.
Yes, sir. That you said that IC is convex to the origin. That means when the MRS is increasing or straight line, the curve that we'll get will not call it IC, right?
No, it is still there, I see, but normally they are not behaving like this. Normally it is behaving convex to the origin. It may be concave to the origin for some very rare case.
Oh, okay.
For very rare case, it could be straight line. For very rare case, it could be convex to the origin, but normally, generally, it is convex to the origin. All of them are IC, but this shape is general. Okay, all right. So, this is end of our class for today. In the next class, we are yes, question.
Sir, আপনি তো ভিডিওটা রেকর্ড করছেন, স্যার ওটা কি দেওয়া যাবে? বা কোথাও আপলোড করে দেওয়া যাবে?
I will provide this in my Facebook page, and you are going to be member of this Facebook page as well. Okay.
Okay, sir. So kindly to fast upload দিলে স্যার আমরা এটা ক্লিয়ার।
Okay. All right. Thank you very much.